is that, all right, we're back on, is that the efficiency of the equipment varies with respect to outdoor air temperature, and gas equipment's not like that. So that's a little bit of a hit on this air source heat pump technology. Also, the other thing I want to point out on this slide is that the currently gas and electric prices are as far apart as they've been in my memory, and it's been trending that way for quite some time. If you go back 10 years, maybe 10 to 30, the difference in cost of gas to electricity was about a factor of 3. Electricity being about 3 times more than gas. And now you can see that we're over 5. So that's also something to overcome. Just want to make a few of those points there.
Thanks, James. Well, let's dive in. Emily, if you can go to the next slide. So let's start talking about different types of all-electric mechanical systems. So James, can you tell us a little bit about Minisplits and what you like about them, where there are challenges related to them, what you see as the most useful application of them?
I'm happy to do that, but I want to go back one slide again. Sorry to be a nudge.
No, that's okay.
Okay, so in our work, we have, because we're really focused on energy efficiency, we take a whole building approach. And whole building means is that we're not just focused on the mechanical system, we're focused on the whole building. And the first and best place to reduce the amount of energy a building needs is the building enclosure. So we really focus on the building enclosure and supporting our clients to understand the benefits of air tightness and the quality of air tightness and what results in the best chance for air tightness, and then also what results in the best chance for resisting heat transfer. And at every part of this enclosure, whether it's the roof, walls, the connection to the ground, there are challenges for how to have a really high-performing air barrier and thermal barrier. But that is where we start, is focusing on that, because that's how we get to a place where air source heat pump technology, for example, can be applied and be reasonably affordable. So one thing I've seen over the years is there's often a misunderstanding that you can add a great mechanical system to a building, not change anything else, and expect great energy cost performance. But I just want to let this group know that it doesn't work that way. We cannot solve for a bad enclosure with a good mechanical system. Simply stated. Okay, I'm ready to go now.
Yeah, so we're assuming that your client has done all the work as it relates to making sure their new construction envelope is to passive house levels, or that they've really done a comprehensive exterior retrofit for their existing, renovation project. So that let's use that as a baseline and assume you've got that under control. Where do you see mini-split systems being deployed? What do you see as their advantages?
Sure. So primarily we're seeing one-to-one mini splits on the types of projects we do, which are large multifamily projects, both affordable and market rate, is we're seeing them now on primarily on market rate. And that's trending away from gas and towards these one-to-one. We call them one-to-one. You have one outdoor unit for equipment that's serving one apartment. And so in the market rate world, the trend is going from gas-based systems that are at the unit level. So the gas metering is at a unit level, to electric systems at a unit level. And that's the reason why we're seeing one-to-one units multifamily, in market rate, but in some affordable as well. When the decision on that metering option, which we had a slide for earlier, has been made to put utilities, in this case, the heating and cooling costs, on the tenant. We have a job that's in design currently that has 290 apartments. So in that space needed category, visualize 290 individual outdoor units on the roof. It's a farm, and that can get a little out of hand. So that's primarily where we're seeing Minisplits and why we're seeing them on those projects. It's primarily for metering.
And you get heating and cooling out of that system. The tenant pays for it. It's typically on the tenant's utility meter. And they're fairly high performance systems, but somewhat refrigerant intensive too, right? There's a significant amount of refrigerant in your building if you use this approach.
There would be. So if you imagine that project that I just mentioned with 290 apartments, for each outdoor unit, we have refrigerant piping that's connecting the outdoor unit with the indoor unit. So yes.
And in terms of the options on these systems for distribution, this image here shows, a wall-mounted indoor unit, which is a non-ducted system. But there's also a scenario for this where you could have your outdoor unit with refrigerant lines that go to an air handling unit within each apartment, and then there would be a ducted fan coil that would send that heating energy around the apartment as well.
That's right. So if you have a 1 bedroom or a 2 bedroom, you can imagine that this ductless unit's not a great solution. So in that case, you can still have a single indoor vertical fan coil unit that can be ducted to provide supply air to the living space, the first bedroom, and then ducted across to pick up a second bedroom, and then you return the air through transfer grills. And there's other indoor unit styles as well with air source heat pumps, both with 1-to-1 and with VRF, which we're going to talk about. So there's a lot of flexibility with this type of equipment in general.
So James, the other place where we're seeing these deployed less on the sort of apartment building side of things, but more kind of low-rise townhome type projects, this seems to be deployed a little bit more often when you think about electrification of those types of buildings.
For sure. And we don't have a lot of those going on right now, but we do have our fair share. And oftentimes those building types don't have a flat roof. They're not as densely settled in that they're not 5 or 6 stories. So there's room for an individual outdoor unit outside on the ground, and that makes it a little easier than having hundreds of units. It makes it a little easier to accommodate a 1-to-1 mini split with individual utility metering.
Great. All right, let's move on to the next system. So package terminal heat pumps. Looks like something we've maybe seen in a hotel before, but tell us about the new generation of these.
Yes, so new generation, exactly. So when you're driving down the highway and you see a hotel, motel, and we've all been in them as well, this is not that. It might look like that, but it's not that. And we don't have much experience with these yet. We're just doing our homework. We actually have a hotel application where they have, it's in Boston, they have significant height limitations. They have no space on grade. So they're looking, and they're not particularly interested in accommodating a lot of mechanical equipment inside the building in mechanical rooms. So this is something that we're doing research on right now for that project to see if we can take some of the heating and cooling load for that building and use a through wall type unit to heat and cool the hotel rooms. So this is a unit that it's called Epic. I'm not even sure if that's how you pronounce it. It's new to the United States. It's manufactured in Italy. We're looking for other manufacturers. These are heat pumps that are sensitive to having an efficient hole in the wall, not like your typical through wall unit. They're also have high efficiency, so they're high quality through wall. Through wall is typically in the marketplace. For the most part, it's a commodity piece of HVAC equipment. This is a new generation, and this company makes another piece of equipment that we're very interested in, which is a through-wall heating cooling unit that integrates the ventilation, the heat recovery ventilation, suitable for one apartment or one hotel room. And I don't want to get anybody too excited about that, but that's something that people have been anticipating would come to the market for a long time. So we're interested in learning about this, but this is very, very cutting edge.
James, are you seeing folks considering this for retrofits as well as new construction?
No, not these. We've done through wall units on projects before. We've even done through wall AC, but there's not enough. And I'd love to hear what other people know, but there's just not enough product yet for us to be even incorporating these on our any of our projects yet. For the hotel project, we're looking at it.
Yeah, I think we've started to hear some news out of like New York City, where they've been trying to deploy some of these on, kind of taller high-rise buildings, very minimal roof area, very little space within the unit to accommodate mechanical equipment. So this little kind of suitcase sitting on an exterior wall is appealing from that perspective, especially like with the retrofits, but I think fairly new and emerging at this point.
Yes, but just to clarify, this is a imagine you're in the hotel room. This is the thing you're looking at that's below the window in the hotel room. This is an indoor unit that has a intake and a discharge connection that penetrates out the sidewall. So on the outside of the building with this particular piece of equipment, you would be looking at a grill that hopefully is nicely integrated into the facade design.
Just a lot of PTHP excitement in the chat, I just realized, and wondering if this works with passive house design and if there's some cold climate usability with this that folks had heard it might not be great for cold climate application right now, wondering if that's been evolved. Some people are wondering if they're loud, and somebody else was wondering about school buildings, if that's where people have also seen them. So it's just a flurry about PTH.
Yeah, that's great. And I can answer them in one fell swoop by saying that this is not that type of equipment that you're used to seeing in a hotel or a school. In a school, they're called unit ventilators. They're often steam or hot water. Basically, this shape, the idea of a cabinet under a window in a building at the outside wall that has a connection to the outdoors, there can be all sorts of guts inside the cabinet. What we're really talking about is new guts inside what we've seen dozens of times in our travels. But these are new guts. This is a completely different piece of equipment. In terms of noise, one of the reasons why we were turned on to air source heat pump manufacturers from other parts of the world was they had completely different expectations and standards for noise than US manufacturers. So I don't exactly know the noise levels of this particular unit that's from Italy, but I do know that they have different expectations and standards for noise from HVAC equipment in general. So I'm glad there's a lot of excitement about these, but hold on. We're really part of. There's a part of this presentation is kind of the bleeding edge, and this would be the bleeding edge. The New York City point is that in New York City, they are really, like I discussed with the new hotel in Boston, they are really hemmed in terms of what their options are. So to answer the passive house question, there's nothing that precludes the use of something like this or a more conventional through wall unit. But when we do deal with through wall units in passive house projects or deep energy retrofits, we're very concerned about the air barrier and what's happening at the unit and how weak a link is that going to be. And then the next thing we would look at is the actual energy performance of the equipment. But I wouldn't be particularly concerned about that compared to the integrity of the air barrier and the impact on the enclosure.
Great.
Experience.
Great. So yet another system that would be on the tenant's meter most likely, and one that has low impact in terms of refrigerant, because your refrigerant loop is all within this piece of equipment, right? So less refrigerant in a system like this by far than something where you're sending lines from an outdoor unit to a more distant indoor unit.
Yes, both points. So yes, the benefit of going on the utility meter at the apartment level, and all of the refrigerant is contained within the unit. So there is no distribution of refrigerant, and that's what drives the refrigerant volume is when it has to be distributed.
Great. All right, next slide, Emily. Let's transition into some of the more centralized heat pump systems. So VRF, you see a lot of these, James.
We see a ton of these. And this is what is on the majority of our projects, but things are changing quickly. And so we have migrated to VRF over the last 10, especially 5 years. And the marketplace is just getting used to VRF systems, which has been great, which has been responsible for prices coming down from estimators and their familiarity with them driving cost, and also more manufacturers coming into the marketplace, which has driven costs down as well. But there's an increasing concern about what we talked about with the last slide, which was these systems are refrigerant piping and refrigerant intensive. So because we have just similar to the one-to-ones, we have a lot of refrigerant piping to get from the outdoor equipment to the indoor equipment, and it would be nice to reduce that. And we'll talk more about that when we get to the next slide. But staying with this slide for a moment, one of the advantages of this system is that you can convey a tremendous amount of energy through refrigerant piping. So the piping is smaller. So that means the piping material is less, the insulating material is less. The space to accommodate the system is achievable, more achievable than ductwork, certainly, and more achievable than running hydronic piping, which is code for chilled water and hot water piping. And another advantage of these systems is they're very efficient. It says yes to efficiency, and they also over the last 10 years, our expectations for comfort appear to have increased. And so 10 or 15 years ago, a typical system could either be in heating mode or cooling mode. And people don't have an appetite for that anymore, especially during the shoulder seasons. So the VRF system, like the one-to-one system, allows for an apartment to be in heating or cooling, depending on what the thermostat in the apartment dictates. So those are a few comments on VRF, but they're very common right now, and they're on the majority of our current designs. This has been a very nice solution to along with the one-to-one, but this one's less material intensive than the one-to-one, a lot less equipment on the roof. They've been a very nice solution to the electrification of heating in buildings, especially, and I would say it's a requirement. It's a requirement that the building enclosure be well designed in order for you not to be surprised by the cost of heating your building.
Great. All right, Emily, let's move on to the next slide. So a slight variation on this. Instead of pulling the heating energy from the outdoor air and transferring it with a refrigerant to the indoor air, air to air heat pump, here we have an air to water heat pump. So tell us a little bit about how that's different.
Sure. So this would be in the category of cutting edge. We've been waiting for this equipment to come to the marketplace, and it was last month that Mitsubishi made their equipment available to the marketplace, as well as when we get to domestic hot water, we'll talk about CO2 based equipment that's also been made recently available to the market, just recently. So what we're doing here is with a goal for reducing refrigerant distribution in the building, we've got this piece of equipment that's pretty generic looking on the right. But what we're doing is we're using a heat exchanger that's not far from the outdoor unit. So we have refrigerant piping that's very limited, that's connecting the outdoor unit to a heat exchanger that's just like it sounds. It's exchanging heat from refrigerant to water. And then the distribution from the heat exchanger through the building is water. And water's a beautiful thing. It's durable, doesn't break down. It's a really great way to distribute chilled water, hot water, or even condenser water, which is associated with water source heat pumps. The concern that we're going to see people having is with cost, because distributing hydronic piping in buildings is relatively costly. The piping materials are larger, the insulation's larger. In many scenarios, in order to achieve simultaneous heating and cooling, we're going to need 2 sets of piping. So that's called a 4-pipe system. We'll have it, one set will be chilled water, one set will be hot water. So there's going to have to be an appetite and an acceptance that we're going to need more space for the distribution, and our distribution costs likely will be higher. The last time we routinely designed 4-pipe systems was in before 1990. So it's been a long time since the buildings that we work on have been able to accommodate the cost of hydronic distribution. But we might be getting into the weeds here a little bit, but it is conceivable that you could have 2 pipes if you're just exchanging the heat to a condenser water loop, which operates in a narrower temperature range than a hot water and chilled water system. But at the terminal end, meaning at the apartment, you're talking about another piece of refrigeration equipment. It would be a water source heat pump, which would have an integral compressor, and but your refrigerant overall, the amount of refrigerant in your system overall would be greatly reduced. We have one of these designs underway currently.
Would you see this being a good solution for retrofitting buildings that might already have 4-pipe systems or hydronic distribution?
That would be nice. The sorts of things you run into with existing buildings, however, is you might have an existing building that has high temperature perimeter hot water for heating, or it might have a condenser water loop associated with a water source heat pump system. Oftentimes when you come to a building that's ready for a capital improvement, there are issues with the existing hydronic distribution. So you might get lucky, but we don't often see that sort of compatibility due to the age of the prior system or something having to do with the distribution of the previous system. It might, for example, it might emanate from the basement, and now we want a system that starts at the roof, something like that. Just thinking off the top of my head. But generally, we generally run into problems trying to mix and match new equipment with old systems. That's just a general difficulty.
Emily, can you go to the next slide? All right, so we're transitioning from heating and cooling equipment more to the domestic hot water side, which we know has been a really challenging nut to crack. And folks have been spending a lot of time and energy thinking about how to do this efficiently and cost effectively. So let's talk a little bit about the different types of options that are out there. So at a baseline, starting with electric resistance. And honestly, as we've had projects who have been trying to move towards all electric, we've definitely seen people considering doing all electric resistance domestic hot water. So can you talk a little bit about, where that might be the right application or what scenarios it might make sense to do that in, even though it's definitely not as efficient as the heat pump based technology?
Well, it's hard for me to think of the right application because if you've been around long enough, there was a lot of electric resistance installed in this, probably starting in the 60s, 70s, and then in the 80s, it was being taken out of schools and replaced with fossil fuels. So electric resistance has been a dirty word for a very long time. And it's basically because where air source heat pumps provide this coefficient of performance in that you have 1 unit of energy in, and you can potentially get 3 units of energy out based on using the outdoor air as a heat source. Electric resistance is 1 unit in, 1 unit out. So you're paying the full cost of that electricity. And if it's 5.4 times more than gas, you are paying roughly 5.4 or 5 times as much for your domestic hot water as you would if it was derived from gas. So this is a difficult solution. It has been said that there's only one downside to electric resistance heat, and it's cost of operation. Everything else about electric resistance is pretty handy. It's affordable, first cost, generally speaking. It comes in all different shapes and sizes. You can even get rid of your mechanical engineer on in some aspects. We've seen buildings that are entirely electric resistance heat, electric resistance hot water. You still need a plumber, an electrician. You don't need, I'm being a little flip here, but it's difficult. People have been excited by the fact that you might be able to make your enclosure so high performing that you can take a hit with the domestic hot water, but I don't see this as a good solution now or moving forward. But it certainly has gotten attention in the last year or so in this push towards electrification, and also the fact that, and we'll talk about this more, domestic hot water is much more difficult to accomplish than heating with electricity through air source heat pumps. Maybe next slide.
It looks like we might have lost Lauren, so we'll have you soldier on, James. I'm sure she'll come back in a minute.
But we're gonna miss her. Hopefully she comes back soon. So heat pump water heater. These have been in the marketplace for quite a while. We've been working really hard to apply them. They do not work well on an individual apartment basis because you can imagine what we're doing is we're using apartment air and we're extracting the heat from the apartment air. So it's not hard to imagine that in order to extract enough heat to make hot water for your kitchen and for your showers, it's a lot. And in a very small apartment, what makes this a no-go is the cold draft that the equipment's going to produce. and it's going to be very hard to overcome probably 3 out of 4 seasons. So we are not recommending this for individual apartment applications. One thing we've done to apply these is we've used the corridor, and we've typically done that in smaller multifamily projects. And we may have an application, we do have applications where we have a 55 plus type occupancy, and we have a single water heater serving three apartments. So then you wouldn't have the individual metering, but it would be it's been a plausible solution. We tried it. The building was built. We received no negative feedback, so we've done it on a few additional projects, but it has its limitations. You certainly, and one of the things we've had to help people understand, we certainly can't use outdoor air as a place to get the air for this air to water heat pump. It's just the climate doesn't accommodate it. What I often tell people is imagine southern Florida, where it rarely gets below 50 degrees. That is a perfect place to have one of these in your garage, because you basically have an infinite year-round supply of heat, and you're going to work at a very high efficiency. Our climate is very different. So why don't we go to the next slide? So this is central electric domestic hot water. And most of our designs right now that are high performance multifamily projects and in Massachusetts are, and this is changing quickly, but most of our projects right now are incorporating central gas-fired domestic hot water systems for now. And they're making provisions for conversion to electric equipment in the future. So the central electric systems require more space. There is a requirement for equipment on the roof. There's outdoor condensing compressor units, just like with an air source heat pump system. So there's some space requirement on the roof, but there's quite a bit of space required inside. And we want that mechanical room that accommodates this equipment to be at the top of the building near our outdoor equipment. It might be feasible that we can have that mechanical room down at the bottom, but you're talking about infrastructure running from the roof to the basement. So we have been placing these mechanical rooms at the top of the building, and we've been starting with gas-fired systems, with having the electrical service be suitable for future conversion, having the mechanical room space that I mentioned being suitable for the conversion. And I know we're running low on time. And also having the structure there to support the weight of water. And everybody knows water is heavy.
So James, I think the last part is just the making sure our all electric buildings are actually all electric. Can you speak to the systems that we might not be thinking of that we might need to convert?
Yeah, and very quickly. So the induction stovetops, I have them in my house. They work great. There's been some adoption of that, but it's been hard to come by. It's hard to get people that are hooked on gas in that case. Dryers in my home, I have a heat pump dryer that's, I have a very tough crowd in my house, and they've accepted it and haven't even complained about it once. ERVs, so we temper and dehumidify the fresh air at its source. Previously, we did that with gas. Now we do it with an air source heat pump. And then emergency generation, this is something that we're working hard in our office to get up to speed. There's been much more information available now in doing emergency generators with batteries rather than diesel or gas-fired generators. So that's an area that we're educating ourselves, and there's a lot to learn.
Great. Thank you so much, James. I know we're running short on time, but we have a few questions in the chat that we want to cover. The first is asking about cross ventilation and wondering if that's key for air tightness, besides relying on HVAC and mechanical systems, especially in affordable apartments, which are tight and limited in openings. So maybe speak a little bit to the importance of ventilation with these systems.
The ventilation has mostly to do with the air tightness of the building. The heating and cooling system is decoupled from the ventilation system. That's been something that's been a priority of ours for years, because one system that tries to do it all does nothing very well. So ventilation is decoupled already. Cross ventilation makes me think of concern about contamination between apartments. But there's really a very small percentage of cross-contamination. COVID has made that the focus. So that's my rapid fire answer to that. But the bottom line is if you know, the old thing, build tight, ventilate right. The mechanical system has to work in a well designed and well constructed building.
Great, thank you. A question about the surge protection or any additional equipment that would be needed for these systems.
Is that an electrical question?
Yeah, I think it's. I think it might have come in during the PTHP if there was any surge protection needed on those.
I'm going to have to take that one, go to an electrical engineer and get back to you.
Great, thank you. And then a question about the usability or the feedback on the usability of this equipment. If it's been, you know, if residents have said that they're comfortable at the set temperatures at night during the day.
This is the air source heat pumps in general have raised the bar in terms of quality of mechanical equipment. That was what originally drew us to the equipment. So noise issues, temperature control, you know, every system can have issues, but one of the reasons why we like air source heat pump technology, and this is outside of the focus of what we're talking about, is the outcome. We can count on an outcome reasonably well that is going to be good.
Well, thank you, James, so much. I'm sorry that we lost Lauren. She's trying to get back in, but we so appreciate you joining us and sharing this. Folks, if you have any other questions, just throw them in the chat and we can email answers as well. And now I think what we're going to do is turn it over to Brooks Winter for a quick announcement, and then to Heather Clark to give an announcement as well. So Brooks, can you unmute yourself then? Great.
Yeah, thanks, Emily. And hi, everybody. Brooks Winter from the Metropolitan Area Planning Council. Just wanted to share some information with you all about a training series that we did recently that some of you might have attended that I think is relevant and kind of parallel to the conversations that are happening here in the Energy Cohort. So Emily and I have been working with Don and other folks through some funding from the Department of Energy Resources on this Affordable Access Regional Coordination Project, we call it, or ARC. And we hosted a series of 3 trainings recently designed for municipal staff, community organizations, and community development corporations and other folks working at the local level, sort of at the intersection of energy, health, and housing. And the first training really focused on those intersections and some of the context about housing policy and how we got to a system of housing and energy that disproportionately burdens low and moderate income folks and communities of color, and explored the concept of the energy cost burden, which is a piece of the housing cost burden, and how that plays out in Massachusetts, and then explored some of the resources that are available for folks on the energy efficiency side, and then on the kind of renewable energy side of things in the second and third trainings. And so I can post the website where all of those materials are posted. We have recordings of the 3 90-minute sessions that were all on Zoom, but we're also going to be posting shorter versions of each presentation so that if you are interested in a specific topic or a specific presentation, you don't have to wait and watch the whole 90-minute Zoom recording. So I'll post the link to that in the chat. Would invite you all to check that out as a good resource for organizations and folks who are interested in connecting people in their communities, maybe outside of your building portfolios with clean energy resources. So thanks, Emily.
Thank you, Brooks. And now to Heather.
Sure, thanks. So I'm Heather Clark with Rocky Mountain Institute. You might recognize me from the past working in affordable housing in Massachusetts on the development side. We're in Massachusetts, we're running a program which is to support deep energy retrofits on existing buildings. The goal being to catalyze the zero carbon building revolution for our existing building stock. And we're looking for buildings to participate in a challenge to get 1,000 units under construction for deep energy retrofits in Massachusetts by 2023. So I'd like people to start thinking about their portfolios and clients that you might be working with who may be interested in doing a deep energy retrofit. And if they're looking for assistance in that, we'd be very excited to help them. You might recognize Castle Square Apartments. This is a project I actually worked with James many years ago. It was the first deep energy retrofit in the US. So a deep energy retrofit is 50% energy savings or more. And we're doing through this program another deep energy retrofit of one of the buildings on this block, the last remaining building that's going to be starting construction this spring. So the concept of a deep energy retrofit is you're super insulating a building on the outside. You're installing ideally all electric, either integrated mechanical pods or other all electric integrated mechanical on the building. And then we're trying to use carbon storing materials. So we're trying to get away from foam and petroleum-based materials so the overall impact of the project is less. So in terms of what we're offering, the sad part is we do not have like a big pool of funding. This is not RMI. We offer free technical assistance to help identify buildings that could fit, but there's not a direct pool of funding, although we can help you try to find some incremental funding for the projects. We're working with owners to identify buildings. We'll be matching owners with manufacturers and designers and consultants that can help you implement the projects. And we're also working with workforce and others and technical sharing. So ideal candidate buildings would be a building that's already scheduled for a major rehab. Maybe it's a 4% tax credit deal or a RAD conversion. Ideally, the project, if we're going to start construction in 2023, funds have already been allocated and that we can just make some modifications. However, we can also get projects in the program that are further down, going to happen later. This planned scope of work for a rehab should already include probably windows, roofs, mechanicals, or siding, so that we're only trying to figure out incremental costs. We're not trying to pay for the whole thing. The architecture should be simple and not historic or architecturally significant. Alston, Brighton, CDC is another, this project Hanna Holmes is another one of our pilot projects. And another example, this is not a pilot project, but this many of you probably recognize 808 Memorial Drive, which HRI is working on. But this is a property where they're doing a new shell, and it's because the building has had significant leakage of water. So this is a great opportunity if you have a building that's already having a lot of water problems or other issues, and you're planning on doing some major rehab to the exterior shell. We can help you really try to get off fossil fuels and make that a deep energy retrofit. So if you are interested, I will put my contact information in the post to share with you in the chat, but we really would love to find some buildings for this challenge.
Great. Thank you so much, Heather. And we'll share that information with the group. And happy to see that Lauren is back on now. And we soldiered on without you, but
great.
Yeah,
it wasn't easy though.
It was. We're happy you're back. Well, now I'm going to turn it over to Neha to explain about our new Slack channel that we're going to be piloting in the Energy Cohort. Neha?
Thanks, Emily. Hi, everyone. I'm Neha. I'm the climate policy intern with MACDC. And we started a Slack group for all of us to be able to communicate in between our Energy Cohort meetings and share resources, relevant events, and other things that you might want to contact each other without Emily or Dawn or Lauren and I like facilitating it. So I'm going to put the link to join the Slack in the chat, and then all you need to do is just make an account, or if you already have one, just add yourself to this channel as well.
Great. Thank you so much, Neha. And we hope that you all will utilize the Slack channel and really share what your promising practices, what your challenges, what you're seeing. And we really want it to be as interactive as possible. So we'd love to hear your feedback on that. And we'll send that out as well with the materials following this meeting. So I think the last announcements from the Energy Cohort and we will have a December Energy Cohort session on December 16th. That's Thursday, the 16th at 1 p.m. And it is going to be on BERDO, Boston's new updated energy reporting and disclosure ordinance, with Brenda Pike from the city of Boston. We're very excited about that. We hope you all can join us. And then we're going to be surveying, we'll send out a short Google form survey to find out what folks are interested in learning for 2022 topics. We've really gone through the survey from the last year and a half, and we've covered most of those topics that you wanted to learn about. So I think we'll put it out to you again, and would love to hear folks' ideas, what you're interested in focusing on in 2022. So the last note is that we are going to be extending the STAR solar program deadline. That's for any affordable housing owner who's interested in on-site solar. We have technical assistance, and so that is going to be open applications until the end of November. So we'll send that out as well. So I think that's all we've got, but thank you again. Huge thanks to James Petersen and Lauren Bauman for a great discussion today. We really appreciate you sharing your expertise with the group. And thank you all for joining us and having great questions and input on this. So really appreciate your participation, and we wish you all a great rest of your day and week, and hope to see you next month and on the Slack in between. So thank you all.
Take care.